Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to talk about compound interest, both the standard compounding that your banks most likely use, and then the real theoretical idea of continuous compounding. So the formula for compound interest is going to be A equals P times 1 plus R over N to the NT, where P is the principal, also known as the amount you initially put in the account. R is the interest rate. And I'm going to put in parentheses as a decimal. So we're not going to put 4% in there, we're going to put 0.04 in there. N is number of times compounded per year. So if it's annual, N is going to be 1, but if it's quarterly, N is going to be 4, monthly, N is going to be 12. Daily, for our purposes, N is going to be 365. And there may be some other interest periods that you'll see. And then T is time, and that's in years. So we could just do the basic thing of you invest $100 in an account that earns 3% interest, compounded monthly, and we're doing that for 12, we'll go ahead and do it for 12 years. So I can just go ahead and punch that into the calculator directly, except we are going to need to put that exponent in parentheses on some of your calculators. So I end up getting that after that time period, we have if I can type, so after 12 years, we end up with $143.27 in the account. But there are a couple of very important things that we can do with that formula. So let me write that formula down again. A equals P times 1 plus R over N to the NT. Now, let's have a little bit of fun. Let's invest $1. And we're going to do it at 100% interest. And yes, I am fully aware that no bank is going to give you 100% interest on a deposit, but and then for 1 year. And we're just going to make a little bit of a chart here of n, and then a. So first I'm going to go ahead and let n be 4. So that would be if we compounded quarterly. So we get 1 multiplied by 1. So let me just do that to the side. So we get 1 times 1 plus 1 over 4 raised to the 4 times 1. But I can actually get rid of those multiplications by 1 and just put it into the calculator more simply as 1 plus 1 over 4 to the 4th. And if I punch that in, I get... And although I'm expressing this with money, I'm going to go ahead and write this to 4 decimal places. So 2.4414. Well, let's try something different. What happens if we compound monthly? And I'm not going to go through and write down the formula again, because all I'd be doing is replacing 4 with 12 in both spots. And in that case, I get 2.61, not 610, 6130. So we can see that we got more money by compounding monthly rather than quarterly. Well, what happens if we do it daily? So I'm going to replace the 12s with 365. 365. And here I get 2.7146. So we can see it got a little bit higher. Well, let's have fun. No bank in the world is going to do this, but let's go ahead and consider 8,760 for n. That's actually the number of hours in a 365-day year. So I can do the same formula as before. 1 plus 1 over 8,760 raised to the 8,760th power. And I get 2.7181. We can see it's a little bit higher than it was with 365, but not by much. Well, we'll take the next natural step and see what happens if we were to compound every minute. So a year is 525,600 minutes. And we can do 1 plus 1 over 525,600 raised to the 525,600. And here we get 2.7182. And it actually turns out, we can see that it really didn't change much at all between hourly and minutely. It turns out, regardless of how frequently I compound, it's not going to get higher than going a little bit further. 2.7182 0.1828, and then that number continues on, kind of like pi forever. So the highest we can get with that is that. But this also leads us to something else, and that is continuously compounded interest. Like I say, in the real financial world, you're not going to see this, but it does have very important applications in other areas. But let's have a little bit of fun with the compound interest formula. So you have A is equal to P times 1 plus R over N to the NT. Well, we're going to do some things with this. First thing I'm going to do is I am going to rewrite this in a very funky way. So it turns out that R over N is equal to 1 over N over R. And then I'm going to raise that to the N over R power. I divided by R, so I have to multiply by R. And then I still have the T. Remember that if you take a power to a power, you multiply the exponents, so that's how I can get away with doing that. Well, now I'm just going to decide I want to make my life easier. That we're going to call N over R H. So that turns the formula into P multiplied by 1 plus 1 over H to the H power, then to the RT power. Well, now we have this thing, and we're told, we figured out in the last example that I did that this 1 plus 1 over H to the H power, as H gets big, it gets close to this number 2.71828, etc. Well, it would be nice if we had a name for that number, which we do. Mathematically, we call that number E. So we now end up getting A equals P E to the RT. So that will conclude this video and also the videos for section 3.1 of the text. In tomorrow's lessons, we're going to talk about the inverse of the exponential function, which is called logarithms. So, I will see you tomorrow.